Hey boys and girls, Mr. D here. In this video, and after watching this video, you will be able to solve a system of equations by using the elimination method. Okay, so let's just jump right in. Let's take a look at a couple of the examples we've got here. And you see here we've got two equations. Please remember, each one of these equations represents a line. And what we're really trying to do is we're trying to find where these lines intersect. So we already did the graphing method, which gives us a lot of times just an approximation. We did the substitution method, which uses algebra to come up with a very specific point, the xy coordinates. Okay, so we use the elimination method here. Again, it's an algebraic method to get us a very specific point. Okay, so here's a couple key tips to keep in mind here. Why don't you press pause and please copy these all down. When you're done copying them, unpause. Okay, so hopefully you've got these all copied down the side. Now we can look at our steps. So the first thing is stack the equations, line up the variables. So we've got our x's lined up, our y's lined up, our numbers lined up. Or as we like to say, line them up, stack them up. Okay, so just make sure your x's are lined up with your x's, your y's are lined up with your y's. Right. Excuse me. What we need here is we need to get the same coefficients. We need coefficients with the same numbers but different signs. Excuse me. So same numbers, different signs. So if you take a look here, the coefficient here, -2. Coefficient here, +3. Coefficient here is 2. Coefficient here is -2. So what we're trying to do is we're trying to get the x's, for example, to have the same number but different signs. We've got -2 and +2. Same number, different signs. This is +2, this is -2. Over here we have +3 and -2. So different numbers and different signs. But we need same numbers, different signs. So we've got what we want right here with the x term. Same number, different signs. This is what we're looking for right there. So once we have that, we're just going to combine the equations through addition or subtraction. Okay? As we do that, -2x, +2x, it's going to cancel each other out. Alright, so then over here we got our y's. +3, -2. Well, that's going to give us +1y, or just y. Over here, bring down our equal sign. 9 minus 4, well, that's 5. So we just end up with y equals 5. Pretty simple there. Yeah, alright. So, now we take this y equals 5, and let's plug it back in. We can plug it back into either of the equations. Erase that so we just see our original equations. Alright, so let's plug it into, I don't know, let's plug it into the second equation. So 2x minus 2 times 5 for y equals -4. It's a 4 there. Alright, so 2x minus 10 equals -4. Alright, 2x, we'll bring over the 10 plus 10 plus 10. So we get 2x equals +6. We should all be able to know from here that x is going to equal 3. So our point of intersection here would then be, remember we got it right as this, 3, 5, because it's a point. Okay? And that's what we got there. Yeah, ta-da! Alright, awesome. Let's take a look at our next example here. So, again, stack them up, line them up. Okay, stack them up, line them up, stack them up. There you go, okay? X's are lined up, Y's are lined up. Perfect. If you look here, look at the coefficients on x. We have 3 and 1. Do not have the same numbers there. They're both positive. Look at the coefficients here on this other, on the y's. We have +1 and -2. So we don't have the same number. We do have opposite signs there. So we're going to have to manipulate the equations here a little bit. I'm going to work to eliminate the y's because we do have opposite signs already. Alright, so in order to do that, it says right here, if none, multiply to create one. So this is, you can add this into your last list there with the stars. And it says in parentheses, we're going to multiply each term. in the equation. So for example, it'll look like this. I really want to cancel out the y's right here. We have a positive, we have a negative. I've got to get the term here in order to cancel out. It has to become a positive 2y. So I can make it a positive 2y if I just multiply everything here by 2. I'll write it on both sides just so I don't forget to multiply it by the 7 over there. So as I do so, I end up with 2x plus 2y equals 14. All right, I'm going to rewrite the other equation just so we can have them right next to each other, stack them up, line them up. Right? 3x minus 2y equals 11. All right, so now let's just combine them through addition and subtraction. Right? So 14 plus 11, 25. Bam. Sorry, I don't know why I'm working from the right side now, but I just am. The y's, they cancel each other out. Voila. 2x plus 3x, well, we know that's 5x. We should be able to see here we divide both sides by 5x equals 5. Sweet. Bam. Alright, so let's plug it back in. Now, again, we can plug it back into either of these equations. Really, we've got our choice of 3 equations if you look at it right here. We could plug it into this equation, we could plug it into that equation, or we could even plug it into this manipulated equation here if we wanted to. To me, and I think for most of us will see, this first equation is probably going to be the easiest one to plug it back into, so let's do that. So x plus y equals 7, well, let's plug in 5 for x. 5 plus y equals 7. Alright, subtract 5, y is going to clearly be 2. Alright, so again, let's just rewrite it the right way. So I'm writing it in xy terminology, 5, comma 2. Right, and so there we are. So again, if we were thinking about it, these are 2 lines, and they intersect at this point 5, 2. So hopefully this helps you a little bit. We'll do some more practice. I think I gave you those 3 practice problems in 382, 7, 8, and 15. Give those a shot. And hopefully this helps, and we'll do some more work on it tomorrow in class. See you guys then.